Thank you for coming to our talk. I know there's lots of other ones going on, so we appreciate you coming to see our talk. We're going to be talking about going from Cloud Foundry to Cloud Native and how to empower application deployment. Why we're talking about this? Well, for those of us who've been around a while, one thing we know is that the only thing that's constant is change, right? So I like this quote from Steve Jobs, where he basically is saying that change is opportunity. This is where we can do innovation. So it shouldn't be seen as scary, right? It can feel scary, but it shouldn't be seen as scary. And the change we're specifically talking about in this talk is around people who've been using platforms as a service for a while. We're talking about Cloud Foundry, but any platform as a service. It's probably starting to say, we're seeing organizations struggling with what we're calling platform decay, where platforms are starting to feel a bit brittle, they're creaking at the seams, and they're not evolving fast enough. And so we want to talk about our journey of having worked with Cloud Foundry for a long time, and now we're together working with more modern kind of cloud native technologies, and we want to share some of our lessons that we've learned and see if they resonate with you all. And this is the spoiler, so if you fall asleep, here's the ending right at the start. We're going to be talking about the good things about platforms as a service, and also some of the gaps. And then we're going to be talking about how they compare to modern cloud-native technologies and how you can kind of expand your platform to be more fit for purpose, let's just say. This could look like things like golden paths that, quite popular, platform democratization. We're going to talk about basically how you can take your current internal platform and make it better. So we'll start with some quick introductions. My name is Paula Kennedy. I am the COO and co-founder of a company called Syntasso. We make an open source framework called Kratix, which is for building internal developer platforms. And I've been in the platform engineering game for a long time. Some might say too long. But I've been at Pivotal and VMware and Cloud Creator before that. I'm a CNCF ambassador, an Open UK ambassador, a team topologies advocate, and I run a bunch of community stuff. So that's me.
Yes, I'm Derik. I'm a principal engineer at Syntasso. I have a much less, impressive CV as Paula. Just write some code. I worked at Grafana, and also at VMware at Pivotal with Paula. Had some certifications around Linux and stuff, and do some coaching and mentoring for some folks. And yeah, also speak whenever I can, especially about Kratix, about platforms. Not as much as Paula again, but.
Some might say I speak too much. Okay, so let's talk about platform as a service. We're going to talk about the good, the bad, maybe some of the ugly. Who here's using Cloud Foundry or knows about Cloud Foundry? Oh, nobody. Look at that. Whoa, a couple of people. How exciting. Okay, well, as you saw from my introduction slides, Derik and I both used to work together at Pivotal, which was then acquired by VMware and then Broadcom. But originally, the Cloud Foundry project was an open source project that was begun within VMware, and then VMware spun it out into Pivotal, and they donated the project to the Cloud Foundry Foundation. So the Cloud Foundry Foundation was formed in 2014. Cloud Creator, which is the company I co-founded in 2012, we were one of the original founding members of the Cloud Foundry Foundation. So we've been working around it for a long time. When VMware donated it to the foundation, they then spun out Pivotal as a company and smushed together a bunch of other stuff. So Pivotal Labs, Pivotal Tracker, a whole bunch of other stuff. But Pivotal was the company that then managed the Pivotal distribution of Cloud Foundry, so PCF, as it was called. So when we were working at Cloud Credo in 2012, we were there when people were just starting to get to grips with Cloud Foundry, basically. So that's what I'm using as my frame of reference. Okay, I'm going to be talking about Cloud Foundry specifically because I know it, but some of the lessons learned, some of these patterns apply to all platforms as a service, right? They're not specific. We're not here to bash Cloud Foundry specifically. It's more like common patterns. It's just that we happen to know about Cloud Foundry. So if you're using things like OpenShift or Vercel, like some of these patterns are common across them. So a little bit of history. The very first platform as a service ever was called Zimkey. It was released in 2005, which makes PaaS 20 years old, which is quite interesting stat. The original intent of PaaS as a whole was to simplify the experience for developers. It was to reduce the complexity and abstract away some of the infrastructure and ops, let the PaaS provider handle that, and let developers focus on writing code. When we were at Pivotal, our head of R&D was called Onsi Fakuri, awesome guy, and he came up with this Cloud Foundry haiku that was quoted by Sam Ramji, who used to be the chief executive of the Cloud Foundry Foundation. So the haiku says, "Here is my source code, run it on the cloud for me, I do not care how." And that is the sort of the magic of PaaS, right? That was the encapsulation of why they were good. It was like developers can just push code and everything else will just work just like magic. Another one of our ex-Pivotal colleagues, James Waters, he used to talk about the value line framework quite a lot. This is really just about allowing developers to focus kind of above the line on the stuff that's differentiated, on the features, on the things that you're shipping to customers that are valuable, and not worry about the stuff below the line, the sort of the boring kind of the context stuff. It's important, but it's not it's sort of undifferentiated is how we used to describe it. Back in like 2016, 17, we weren't talking at that point about cognitive load. It wasn't really a term that we used. But PaaSes were able to reduce cognitive load for developers, particularly folks who are trying to do DevOps, right? Build and run everything yourselves. A PaaS allowed you to actually focus above that value line without worrying about too much of the infrastructure stuff. We saw the rise of PaaSes kind of in line with things like, so you had like software as a service, platform as a service, infrastructure as a service. You had all these different kind of rises of things as a service along with cloud computing, right? They all sort of became popular at the same time. One of the great things about PaaS was that self-service experience that actually developers were starting to look for. So people were getting used to using AWS or other consoles where they were point and click, get a thing when I want it. That was the experience developers were getting used to. And that was a thing that PaaSes have been very good at. Right? They can provide that on-demand self-service experience. This is a screenshot from Apps Manager from Cloud Foundry. It doesn't really matter about the detail, but the idea is that the developers can just see some of the services that are running. They can take some actions on those services, stop them, pause them, look at them, and they don't have to wait for someone else to do anything. There's no ticket that has to be raised. There's no backlog. It's just doing something self-serve on demand, which is great. And another great feature of PaaSes was around some aspects of fleet management. So in Cloud Foundry, you have the concept of build packs, which Derik will talk a little bit later on in the demo. But the detail doesn't really matter. The point is that with a build pack, platform teams were able to make updates that then could be applied at kind of the application layer across multiple application instances without the app teams themselves having to do a whole bunch of work. So it was enabling sort of this some aspect of fleet management, having some broader control to be able to roll out things like updates, for example. So with all that goodness, right, the reduced complexity, the self-serve experience, and some fleet management, why isn't everybody using PaaS? Right? It's once upon a time, I used to ask myself this question a lot, but I quite like this quote from Kelsey Hightower. So it's a little sarcastic, right? Kelsey's kind of implying that everyone wants a PaaS, they just want to build it themselves. Engineers are going to engineer, right? That's kind of a vibe. But there's some truth in that, right? There are some limitations and gaps with PaaSes that we've learnt in our journey. And so let's have a look at them. When we were at Pivotal, one of our customers, big UK bank, said this, right? Cloud Foundry is great for my 12-factor apps, but what about all the other workloads that I'm running in my bank? And that's quite common, right? PaaSes are very good for certain types of workload, but if you're a large organization, financial or otherwise, if you're a large-scale organization, you have got masses and masses of tech that you need to run, and PaaSes typically can only manage a small amount of it. The other challenge we heard a lot when we were at Pivotal is that when you're buying a platform as a service, you're buying the opinions of that PaaS provider. So they're baked in. There's some amount of customization, but as soon as you're trying to put in your own workflows, your own business logic, your own requirements, it feels like you're trying to crack open a black box, right? There's some amount of customization, but typically not enough, and we heard that a lot when we were at Pivotal. So to summarize, PaaSes are good. I'm not trying to say PaaSes are not good. It's just that they're not quite good enough, right? They do offer some good experience around kind of the reduced complexity and the self-serve, etc., but there are some gaps. So how can we, in 2025, with the rise of Kubernetes, cloud-native technologies, how do we take all the goodness of PaaS and then expand on it and actually make our platforms more valuable, more useful? And luckily, Derik is going to show us how.
So let's just take a step back and think about what Cloud Foundry did. That was great, right? Like I still remember the first time that I actually used Cloud Foundry as a developer. That experience was great. You just go to the terminal, you have your Rails app, CF push, it's running, you have a URL, it's there. I don't have to worry about setting up root and DNS. I don't have to worry about deploying VMs or anything really anywhere. I don't have to worry about firewall. I don't have to worry about anything. I just can focus on actually building and writing my code. So that was great. We want to reproduce that. We want to still give our developers that experience, right? But that's kind of what the haiku says, right? The developer wants that experience. Here's my source code running the cloud for me. I do not care how. However, your organization does care how. And that's where the things start to get a little bit complicated, right? There's stuff that needs to happen that is exclusive to your org that is kind of important and you need to take care of. So let's take a quick look behind the scenes and what actually happens when someone does a CF push. This is a very simplified diagram. If any of you know more than Cloud Foundry than myself, you're probably going to be like, where is that component? This is just a simplification. But basically, when a developer does a CF push, the CLI will, in a way or another, package that code and send it to the cloud controller. The cloud controller is the API and is responsible for actually running the code, right? Like doing the steps that it needs to do to run the code. And what does it do? It uses build packs. I think Paula touched on build packs already. To determine how to package and compile that code so it can be executed. So again, as a developer, I wrote my Rails app. I have no idea how to run it. All I've done in my machine was like Rails server. That's all I know. That's all I did. How do I run that in the cloud? I don't know. But the build pack knows that for me. So I can just give it the code. It will compile it. It will make a package, which in Cloud Foundry is called a droplet. And that droplet is the package, the code, plus any compiled files, any compilation, any actually software bundle, plus all of the instructions and everything that needs to run. That droplet will then be sent to a Diego cell. A Diego cell is where the application actually runs. And here we go. You have a running app. There's many other components involved. There's the Go router. There's the blob store. There's all other stuff that will give you like the access, the endpoints, and all those kind of stuff. But in a nutshell, that's kind of what happens. So you push the code, you build something, you execute that something somewhere, it runs the app. Now the question is, how do we do that? How do we produce that in Kubernetes, right? Like if you've used Kubernetes, you know that it's great if you know how to write a lot of YAML. So we want the same experience, right? We don't want to tell the developers, hey, here's a namespace, go nuts. Because they don't know, they don't want to know, right? Like they don't want to care about how to write the deployments, the pods, the service, the ingress, any of those rules. So what they want is the same CF experience. So let's take a look at what that is, right? Like very simplified, this is what it is, right? We want to code, we want to build, we want to run. Kubernetes is great at running stuff. We know that. You can give the deployments, the service, the ingress, the namespaces, the service accounts, whatever you need, it will execute that for you. Developers know how to code, allegedly. So that doesn't change as well. We don't need to do anything necessarily to enable them to code, right? They will continue to code the way that they coded before. So what we actually need to provide is that piece in the middle is the build. Is how do we actually go from source to running on Kubernetes. So let's expand that a little bit. So basically, it's two things needs to happen here. Very simplified. There are many other things that need to happen, but there is basically two steps. One is you need to build a container image. If you're running things on Kubernetes, you're probably running it based on images, container images. So you need to build the image from the code. And the second thing that needs to happen is you actually need to generate some Kubernetes objects. You need to get the YAMLs, basically, out there so you can actually execute them in Kubernetes. And that's where Kratix can help. So Kratix is the tool that we built at Syntasso. It's a framework for building platforms on top of Kubernetes. And the main concept of Kratix is a promise, not a JavaScript promise. It's just a promise. It's a representation of something as a service. It's basically what the platform team promises the user that they will do when you send a request for that. So this could be a database. So we promise you a database. You send a request, we'll create one for you. And the promise is nothing more, because it's Kubernetes, of a YAML file, right? And it has four main components. The first one is the API, which is what are the bits that the user can actually configure. For example, if I'm deploying a source from code from my source, I may need to specify where I can find the source, the GitHub, the GitLab URL, right? it has the dependencies. What needs to exist before I'm able to run that particular code? So if you're running and serving it via Nginx, you may need an Nginx instance running somewhere, or like an installation of it somewhere. And it has how we have the workflows. Workflows are a series of steps that you need to run, to execute, to actually fulfill the promise. And you also have destination rules, which is like, where does this go? So if you remember back to Cloud Foundry, you have the Diego cell that would receive the code. In Kratix, we have something similar that you can say, well, this goes to that cluster, or this goes to that VM, or this goes to that Ansible hack, or anything like that. And then you have Shipwright. Shipwright is a framework for building containers in Kubernetes. It can use popular tools like Canonical, Cloud Native build packs, and build out to actually build containers based on source code. So that's kind of where the two things meet. And Shipwright works pretty much like this, very simplified diagram again, but it has 4 main components. You have the source code itself, which is what it's going to build it from. You have the invocation. It's basically like when you tell Shipwright, can you build it for me? That's the when. And that hits a build strategy. So the build strategy is a document that describes how and in which way you want to build that image. So it has, and that's where you specify what type of build packs do you want to allow, what type of technologies and languages and all of that. Once you get all these 3 things together, it outputs an image for you, and that image can be executed. So if we circle back to the diagram we had before, so what we need to build in our new platform is a promise that can invoke Shipwright, and that same promise can also output the documents that we need, referencing that particular image that is being built by Shipwright. We send that blob of information to the Kratix scheduler. The Kratix scheduler will find a Kubernetes cluster that can run that workload, and we run that for us. And here's my version of the haiku. That is change it, touch as my code, build new container images, shape fresh YAML files. Not mine, actually. ChatGPT built it for me. I'm assuming it's right. But yes, I think we can actually go to the demo. And I'm just going to swap my laptop. This is a background. I just leave it for a shock effect. There's no actual icons here. All right, so what we actually want, what I have here in my machine, is a Kubernetes cluster. I actually have 2 Kubernetes clusters running. And as you can see, let me increase this a little bit. So we have a Kubernetes cluster on the top that is running Kratix. And I also have a worker cluster that is the equivalent in this particular context to my Diego cell. It's actually running my application. So you can see they already have a Java app running there. And here in the bottom, I'm in contact with my platform. So if I do kget promises, I can see what are the services that I have available in my platform. So right now, I only have 1 service available. Oops. Which is the application promise, which is like the equivalent to the CF push sort of application promise. And I have, as I said, 1 application running that is my Java app. Kratix also works really well with portals, if you like those. So for example, here is the same view, but on Backstage, right? Like this showing like what are my promises that I have available. The user can go over here, click create, and fill the form. So maybe, I don't know, maybe I want to do deploy my to-do app, and then they can go and fill the form and do all of that if that's what they want. I'd rather do it in the terminal. But yes, so the user can now, with this platform, go and use that application promise to deploy the application. So what does a request to that application look like? It looks like something like this. So you can see, I hope you can see, that we have a spec. That's the API that we talked about. That's the API of my promise. And I'm saying here, find my source code in this Git repo. It's in this URL, it's in this path. I want to expose this service port. I want this number of replicas. This API is fully controlled by you, the person writing the promise. So you may not want to display the number of replicas. You may not want to specify ports, or you may want to do some other bits. I think if you're familiar with Cloud Foundry, you know that you can specify stuff in the manifest. This is kind of like what are the pieces of configuration that you need to run this application. So at this point, I could come over here as a developer and apply. So what Kratix will do on the back of this is actually kick off the workflows. So you can see right in the top that we have a new workflow being executed. And what this workflow is doing those 2 steps. First, it's going to invoke Shipwright to build the image, and also it's going to generate the documents to deploy it in my worker cluster. And fingers crossed, in a few seconds, we should see those things showing up in my worker cluster in the bottom. So Kratix found a place and say, okay, I'm going to send this to the worker, and I'm going to execute and run it there. And at the same time, I also populated Backstage automatically with like, oh, here's my new application. So you still have that view if you want those. And that took long enough that my Shipwright build started. So you can see that my go up here online on this line, this is the Shipwright build. It's not ready because it's actually building the image. I can go and actually take a look at the logs, if I can do that quite quickly. You can see that it's doing the necessary bits to deploy or to build my image. Takes a little bit of time because it's building image, but I already have the Java one here, and you can see that it did all of that you would expect to build a Java application, like downloading half the internet with a Maven and all of that. So this is all Shipwright. Shipwright is using the Java build pack to build the application, and then it built it, it pushed it to my Docker registry, and then my application itself, my deployment that was pointing to it, got the image. You can see that my application is actually failing right now. Kubernetes is eventually consistent. So eventually that image will be built. Eventually that image will be available. So eventually that application will start. That's a choice. You could like build it first and then push the application. It's up to you. Okay. So this is going to take a couple minutes. So I'm not going to necessarily stop here and wait. Although it would be really nice if it could just magically work right now, but it won't. Cool. But that's kind of like to show that we can reproduce that Cloud Foundry experience, right? We have now an application, the application was pushed. I, as a developer, all I had to do was write something that looks like this. I could embed this into my CI/CD workflows that would just like touch this and update this as the code is changed. And I don't actually have to worry about wiring anything out to run this application. So the second thing I want to talk about is like, okay, now that we build a similar experience, how can we go beyond that particular experience, right? So one thing that Paula mentioned was like how hard it is to actually customize your platform when you buy it in a box, because you have to open the box and customize it. Kratix is the promise itself is just a YAML file that is relatively large. It has many things, but what it also has is a list of steps. So you can actually see here all of the steps that we are going through. So we're using a step to build the image, or basically invoking Shipwright. We have a step to deploy the application. We have a step to add health checks. And I'm actually going to apply a promise now that has a new step, and a step that goes to and do a security scan, which is a step here in the bottom. So whenever I do that, what Kratix will do is find out, okay, what are the applications that I have deployed, and I'm going to re-reconcile them. So you should see in a second or two, new pipelines starting up at the top, one for the Go app and one for the Java app. So I have those two apps are being executed through this new step, through this new definition of the promise that includes that particular security vulnerability scanning. It's going to run. It's going to take a couple seconds. And by the way, my Golang app started as we speak. So the image was built, the image was pushed. I can actually, while the pipeline is running there, I can get my application. I can access it via the URL. It's a very exciting application that is just responds per word. But it's kind of just to prove like my application is now running. It's running in the not in the cloud because it's a kind cluster, but it could be running in any Kubernetes cluster out there. So cool. So my pipeline is running there. I don't know why it's taking so long. Probably the conference Wi-Fi. But while that runs, I think the next thing that we want. Just because I mentioned it, it stopped. It finished. So cool. So it run that the security scanning. I can actually come over here in my Backstage because that's quite a little bit nicer to see, and I can take a look at the results of it. So I can say, hey, the security scan succeeded for my Golang app, which is great, and for my Java app, as one would expect, it fails because it has loads and loads of dependencies. Some of them are outdated, have high critical vulnerabilities. So the developer can now be notified. You can send an email, a Slack message, fail the pipeline, stop the deployment at this stage, but you're now adding your own business rules to this particular promise. And the final thing that I want to show is that it's also that simple to extend and add more services to your platform. So why stop there, right? Now that you have a way to deploy applications, you can also add databases, you can add cache, you can add Redis, message queues, you can add whatever other service you need. We have a marketplace of promises, so you can find the Postgres promise that I'm applying right now, but you also can also find some other stuff like Rabbit, Slack notifications, or Knative, or anything. But you are now extending your platform. You're using the same interfaces to say, okay, now I actually want a Postgres database. And the API looks similar, looks the same, but I can now apply it, and I can get the same steps will happen, right? We're going to run a pipeline, we're going to execute it, and then in a minute or two, we're going to start to instantiate a Postgres somewhere in here in my Worker cluster. But this could be a Postgres in the cloud. This could be something using Terraform or anywhere, really. And I think that's all I had. How I'm on time. OK, that's not that bad. Swap it back.
We're in the final stretch. So thank you, Derik, for the awesome demo. Hopefully my slides will come back up. So, as Derik just showed, right, it's easy enough to recreate, easy enough, I say that because I didn't do it, relatively easy to recreate that Cloud Foundry experience as we talk about, or the PaaS experience. It's just, here is my code, run it on the cloud for me, I don't care how. You can do that with Kubernetes, you can do it with Kratix and Shipwright, you can recreate that experience. But really the point is not just about recreating PaaS, the point is about how do you get a better platform, how do you get a more useful platform, a more valuable platform, right? So Derik's been able to show very quickly how to extend it with things like adding in extra steps. So we call them stages in Kratix, but it's about like the security scanning, or it could be a notification to billing, or it could be something around governance. It could be a manual compliance step, but you can build in extra business logic into your platform, right? And the difference here is it's not a black box that you're cracking open. With Kratix specifically, it's a composable framework. You build in the things that you need and you make it fit for your business. So you can extend it by having in this business logic. You can also extend it, as Derik showed, with things like state, right? The idea with something like Kratix is that you can make your platform work for more types of workloads. So then you end up with a more standardized experience for your developers, so that they're not doing different things with different types. If you've got people moving between different teams, they have a more standardized experience because it's one platform that serves more of your workload and more of your kind of state. So those are the things that Derik tried to show very quickly. You did a good job, Derik. Well done. But there's other stuff, right? There's actually loads of other stuff that we haven't had time to talk about. So some of the extra cool things that you can do, right? We talk about fleet management. We talked about build packs very briefly, but with something like Kratix, you can fleet manage across many more types of resources, right? That's something that we do. Golden paths is something that I mentioned at the start. In our framework, you can put those promises together. We call it a compound promise. If anyone's using something like Crossplane, you might have heard of like composite resource definitions. It's a little similar, but basically you can wire promises together. So you give this golden path experience that covers probably 80% of use cases. Developer clicks one button and they'll get an environment, and it might also have like some messaging. It might have some Slack. It has everything built in, and all those promises are wired together. Another thing we talk about, which again, haven't had time to show you, is platform democratization. So I mentioned at the start, cognitive load for developers. There is also cognitive load for platform teams. So a thing I talk about a lot is when you're asking your internal platform team to build everything and be experts on everything, which is a big ask. And so democratization, a bit like inner sourcing, you get all of your teams in your organization to contribute their own promises. You get the best experience of all of your teams. They can write their own promises that can plug into the platform, so the platform team don't need to be experts on everything. And then finally, this thing about kind of floating versus sinking platform, it's a Gregor Hoppe thing. I don't know if anyone's read his book or seen him talk. Anyway, it's essentially what he talks about is your platform needs to continue to evolve and continue to be fit for purpose, right? So obviously we haven't mentioned AI, so is it really a conference if we haven't mentioned it? AI, the new hot thing, your platform needs to be able to adopt it, bring it into the platform, make it available for your developers. And who knows what the next thing's going to be, right? We don't know. We know that change is constant. So the next new thing that comes in, your platform needs to be able to take the best of new technologies, adopt them, bring them in, make them usable. Your platform should not be static. It should be constantly evolving. And therefore, Gregor talks about this concept of your platform should be floating. It should always be able to absorb the latest technologies and constantly be floating and adding value on top. Otherwise, it's sinking, right? Because other technologies are going ahead of it and your platform ends up sinking, becoming legacy, decay, etc. So you can find out more by talking to us now. You can obviously talk to us at Syntasso if you want to. We probably don't have time for questions, actually. I think we're a bit over. So, but if you have questions, you can come find us. Thank you.